Hello everyone and welcome back to the Advanced Fighter Jet channel. History of the Lockheed Martin F-35 Lightning II. The F-35A's first flight. First flight, the 15th of December 2006. Introduced. F-35B, the 31st of July 2015, USMC. F-35A, August 2, 2016, USAF, United. Status: operational. Main users: United States Air Force, United States Navy, United States Marines, British Air Force. Production year: 2006 present. Production amount: 920 plus as of May 2023. Program fee: 1.508 trillion United States dollars. Machine: Pratt & Whitney F135, PW-100. Maximum speed: 1,960 km per hour, Mach 1.6. Pallet: 50,000 feet. Ability: low surveillance stealth, advanced sensors, network capability and data aggregation. Helmet-mounted sight. Weapon: AIM 120 AMRAAM. AIM-9X, Sidewinder, short-range air-to-air missile. GBU-31 Joint Direct Attack Munitions, JDAM, guided bomb. Laser-guided bombs. Internal 25 mm gun GAU-22, A. The Lockheed Martin F-35 Lightning II is a single-seat, single-engine, all-weather multi-role fighter designed to perform air superiority and strike missions. It is also capable of providing electronic warfare and intelligence, surveillance, and reconnaissance capabilities. 9 countries are involved in its development: the United States, Britain, Italy, the Netherlands, Turkey, Canada, Denmark, Norway and Australia. The F-35 is designed to replace its aging inventory of combat aircraft including the U.S. Air Force's F-16s and A-10s, U.S. Navy F/A-18s, U.S. Marine Corps AV-8B Harriers and F/A-18s, and the UK's Harrier GR.7s and Sea Harriers. With advanced aerodynamic performance and integrated avionics, the F-35A provides next-generation stealth, enhanced situational awareness, and reduced vulnerability for the United States and allied nations. The F-35's engine produces 43,000 pounds of thrust and consists of a 3-stage fan, 6-stage compressor, annular combustion chamber, single-stage high-pressure turbine and 2-stage low-pressure turbine. The F-35 is a product of the Joint Strike Fighter (JSF) program, which was an amalgamation of various fighter programs from the 1980s and 1990s. One of its ancestral programs was the Defense Advanced Research Projects Agency, DARPA, Advanced Short Takeoff, Vertical Landing, ASTOVL, which ran from 1983 to 1994. ASTOVL aims to develop a replacement for the Harrier jump jet for the U.S. Marine Corps, USMC, and the British Royal Navy. Under one of ASTOVL's classified programs, the Supersonic STOVL Fighter, SSF, Lockheed Skunk Works conducts research for a supersonic stealth STOVL fighter intended for the U.S. Air Force, USAF, and USMC. The main technology being explored is the shaft-driven lift fan, SDLF, system. The Lockheed concept was a single-engine Canard Delta aircraft weighing about 24,000 pounds, 11,000 kg, empty. ASTOVL was renamed the Common Affordable Lightweight Fighter, CAF, in 1993 and involved Lockheed, McDonnell Douglas, and Boeing. In 1993, the Joint Advanced Strike Technology (JAST) program emerged after the cancellation of the USAF's multirole fighter (MRF) and the U.S. Navy's USN Advanced Fighter Attack (AFX) programs. MRF, a program for the relatively affordable replacement of the F-16, was scaled back and delayed due to the post-Cold War defense posture, which reduced the use of the F-16 fleet and thereby extended its service life and increased budgetary pressures from the F-22 program. The AFX, originally known as Advanced Attack AX, began in 1991 as the USN's follow-up to the Advanced Tactical Aircraft ATA program to replace the A-6. The A-12 Avenger II produced by the ATA program was cancelled due to problems and cost overruns in 1991. That same year, they discontinued the Naval Advanced Tactical Fighter (NATF), an offshoot of the USAF's Advanced Tactical Fighter (ATF) program. To replace the F-14 resulted in the addition of additional combat capabilities to AX, which was later renamed AFX. Amid increasing budgetary pressures, the Department of Defense
the month of May brought the arrival of the Air Force's first two production model F-35 Lightning II stealth fighters, known as AF-6 and AF-7. The F-35's were ferried to Edwards from Lockheed Martin's F-35 final assembly plant in Fort Worth, Texas, to begin their flight testing programs.
The primary role of AF-6 but rather to develop requirements, mature technology, and demonstrate concepts for advanced strike warfare.
Testing. AF-6 and 7 have the same aircraft hardware and software.
The first F-35A, designated AA-1, was launched in Fort Worth on February 19, 2006 and first flew on December 15, 2006.
In addition to these two aircraft, 8 more production model F-35s
was
have rolled out and are being prepared for
after
delivery.
The World War II
the F-35
Lockheed
program is still just
P-38
getting started. We're at 1 year.
Some USAF pilots
we'll
nicknamed the plane Panther instead.
In 2012,
the aircraft software is developed as 6 releases or blocks for STD.
Model.
The first two blocks, 1A and 1B, prepare the F-35 for initial pilot training and multi-level security. Block 2A enhances training capability, while 2B is the first planned combat-ready release to the USMC's initial operations capability.
A total of 1,763
Block 3I retains
are planned for
2B
production.
capabilities while
Jet
having
Fabera,
new hardware
Edwards
and
Air
is
Force
planned
Base,
for the USAF
California.
IOC. The final release for the SDD, Block 3F, will have full flight coverage and all basic combat capabilities. In addition to software releases, each block also includes avionics hardware updates and air vehicle upgrades from flight and structural testing. In what is known as concurrency, some initial low-level production LRIP aircraft lots will be delivered in an initial block configuration and eventually upgraded to Block 3F once development is complete. After 17,000 hours of test flights, the final flight for the SDD phase was completed in April 2018. Like the F-22, the F-35 has been the target of cyber attacks and technology theft attempts, as well as potential vulnerabilities in supply chain integrity. Tests uncovered several key problems. The early F-35B's fuselage experienced premature cracking. The F-35C's catcher design was unreliable. The fuel tanks were too vulnerable to lightning strikes. The helmet display was problematic, and more. The software has been repeatedly delayed due to its unprecedented scope and complexity. In 2009, the DoD's Joint Estimation Team, JET, estimated that the program was 30 months behind the public schedule. In 2011, the program was rebased, namely, its cost goals and schedule were changed, pushing the IOC from its 2010 plan to July 2015. The decision to test, repair defects, and start production simultaneously was criticized as inefficient. In 2014, Under-Secretary of Defense for Acquisitions Frank Kendall called it acquisition malpractice. The three variants share only 25% of their shares, well below the anticipated commonality of 70%. The program was heavily criticized for cost overruns and projected lifetime total costs, as well as a lack of quality management by contractors. The JSF program was estimated to have cost approximately $200 billion to acquire in a 2002 base year when SDD was awarded in 2001. In early 2005, the Government Accountability Office, GAO, had identified major program and schedule risks. The costly delays strained relations between the Pentagon and contractors. In 2017, delays and cost overruns have pushed the estimated cost of acquiring the F-35 program to $406.5 billion, with total lifetime costs, through 2070, to $1.5 trillion in dollars that year, which also includes operations and maintenance. The unit price for the F-35A for LRIP Lot 13 is $79.2 million. Delays in development and operational tests and evaluations are pushing full-rate production through to 2023.